not saying that we're getting more power out. We're just saying that we're managing energy between two circuits. So you can have two different circuits doing two different things and still it just splits the energy. That means that they're not getting the full benefit, but it's still in a positive range. So yeah, you can
Yeah,
split energy. You
yeah.
know,
We just made a demonstration that it's not violating the laws of physics. Like
yes.
it's not the same. Like for example, if I move my car, if I push it 1 meter, I spend 500 watts. But it's depends on the time that I did it. If I did it in 5 seconds, maybe I spend the 500 watts. But if I did it in 5 microseconds, then I did it with 30,000 watts or I don't know, whatever. But we're not violating the laws of physics. We're just distributing the energy, as you mentioned, like in a faster way, in a more efficient manner.
Yeah, you
Yeah.
know that a chart a a charge pump does the same thing. You have two capacitors. If you attach them together and you pulse it really fast, you get double the voltage out. And they call it a voltage doubler or a charge pump. They have different names for it. But if you have one capacitor and you're doing the same thing, you're just getting the same energy out. But if you split it between the two and you ask the question, how am I getting double the energy out? And because both of them are contributing energy, but they're alternating. And this is what Nikola Tesla is all everybody has been talking about, how you can overlap something. So if you wanted to put it in an example, if you took a string and attach it to a magnet, and every time you pulse that magnet, the string would move. You would see a wave go down to the end that has a post. Now that wave, once it hits that little anchor or post that you have it to, will bounce back and you'll see the wave coming back. Now, if you don't put any more energy on there, it the wave stops. But when you pulse it at the exact time that the wave hits the magnet again, it doubles the wave. Okay. And if you keep doing that, okay, so this is what we talked about, synchronizing energy. And this is what Nikolai also talk about scalar waves and how you can actually scale these waves up from just the same energy that you're applying into it. And it's, if people don't understand the technical terms that I'm saying, it's like going on a swing. If you're pumping your legs and your back and forth of your upper body at a specific time, the swing will go higher. But if you don't do that, then the swing will stop swinging, period. So once you understand the timing of the swing going back and forth, you start to understand that it's a specific time that you can pulse this energy and you'll get to a higher level of energy. And Nikola Tesla describes this. It is usable, and scientists use this type of stuff all the time. So, yeah,
Yeah.
what we're
And
just talking about is energy management.
this guy saying, notice how he skipped the fact that he admitted there is no free energy in the pulse. There is no free energy, like no free energy. The energy is already stored, but the difference is in what is the speed that is being released. It's not the same that you release it yourself, that you get the help from the speed of light to release this energy. Because in this case, we're getting the help of the speed of light to release the energy. That's where you could say the extra energy is coming from. It's from the speed of light. Because the speed of light is pushing the magnetic field towards the coil at a really fast rate. The only thing that limits the rate of speed is the air and the rest of the components. But
Let me ask you a question. If you have a battery, can you charge your battery at 100 amps?
Well, yeah, I guess.
You can charge your 12-volt battery at 100 amps.
That's a little bit too much, I guess, but I think you can
Yes,
do it, right?
that that's exactly right. It's too much. The recommended amps that they want you to charge your battery is at 20 amps at max, so you don't destroy the cell. That means what you start to see is the liquid in there starts to boil off, and you'll start seeing the steam or the smoke coming out of the battery. The Because you're actually damaging the battery. Now, with that said, if my battery has 100 amps and I can only charge it at 20 amps, can I release more than 20 amps off the battery at one time?
Yes, you could with this collapsing field energy.
So would that be called in the frame that I stated? Wouldn't that be called that I can have more power coming out of the system than I can put into the system?
Yes, power, yes.
Okay. So I try to describe this because with that terminology, if you use it correctly, there's a lot of other systems that's stored energy, and then you have stored energy that you can take off more for a small duration of time, energy than you're putting into the system. So when you're doing this and you understand what you're doing, then that
Right.
means that if you have multiple batteries and you want to double the energy because you can only put so much energy into it, then it all results to time related. So this
Exactly.
is
Exactly.
this is how I came up with the theory of over unity, and I'm talking about the dictionary words over plus unity, using it from the dictionary, what those words mean. And when you use it in the correct terms, they never wanted this out of there because what happened is that I can keep running my systems and putting a battery in a water wheel simulation, and then the energy that is going into a battery, you're pouring that same energy out. And if you do that fast enough, that means the switching between the two, it seems like you have infinite energy, even though it is coming from stored energy. So I
Yes.
have,
Yes.
yeah,
Let's go back
we
to
can
it.
do that with capacitors too.
Yeah, yeah. Let's just go back to it real quick. I just want to show that one more time. Okay, I'm sharing my screen, right? You guys can see it.
No, I can't see it yet.
No, not me.
Uh, sharing your screen. Okay, now.
Yeah.
Yeah, yeah,
Okay. So let's just go back to it because this amount of work that is being done in the 33 microseconds in this pulse, it was just one pulse. But what happens if you could pulse it a lot of times with a device like a MOSFET in this case, as you have mentioned? The MOSFET can turn it on and off, on and off, on and off. So this cycle that we just talked about can repeat, and we can be continuing to generate this and even more power, probably a lot of more power. So the power, yes, it's growing the power, but as you can see, this is telling us that the energy is conserving. It's only 5 joules, but the issue comes uh, when you are releasing that energy in such a small amount of time. This
right.
is giving
E
you
over
more
delta
power.
times time.
Notice how it's not giving us more energy. It's giving us more
Right,
power, but it's not giving us more energy. It's the same
right.
energy released in less time.
Yes.
Yeah. So that's where everything matches, and that's why we need, like, the as you said, like the pulse. This is only one switch, one switching. When we can keep doing that all the time, like in a way to generate the sine wave,
Right. And this is what your MOSFETs do if people don't understand.
Yep. Yep. All right, guys. I just wanted to show that, but I have to fly right now. But
Okay.
thank you.
Thank you.
Thanks for sharing.
Yeah. 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 Thank you, guys. We'll keep in touch. Cheers.
Cheers.
Hmm. Chris, you still with us?
Yes, yes, yes.
Anything else you wanted to ask? Because, like I say, we covered everything. We got through it. So, again, anybody got more questions?
Maybe my question will be just like this part. I think I will post it first. Like, what does anyone need? Like, say you have a solar panel and you want to be able to run your system at night. What component like should one go and buy, and which type of LEDs? There's a question I'd seen one time. Somebody asking if you need a specific type of LEDs or you just need any, because there's an issue to do again with the wavelength, I think. So
Okay.
what does a
Put up.
person need? Let's say somebody's watching right now and they want to try out this. What do they need to go and buy? And
Okay.
yeah.
So, here's the thing. Put up the picture of this in the thing about the LEDs and the solar light.
Yes, as I put up, you can say maybe what does a person need, but I'm looking for it. You still around or you're frozen?
Can you hear me? Can you go into your WhatsApp, get the picture of the person holding the LED light over the solar panel, and it says 145 volts.
Yeah, don't forget that when if you put these the solar panels at sun, it will give you 180, but it's LED lights. Just for comparison.
Yeah, that's what we want to show. We want to
Yeah,
show a comparison on that. He asked what type of LEDs, all that. That picture answers a lot of questions.
yeah.
Pierre Dusa is saying that there's nothing like free energy if your definition of free is strict. Uh,
Well, again, it depends on your definition of free energy. Free energy, like using water or wind. Again, the energy that comes from that comes from nature. And if I take and chop down a tree and I burn it, the only people who's going to charge me money for it is people who are running the system. Otherwise, that's just the labor of what I put into it to chop down the tree.